Hello students. So today we are going to start the new module for this particular week, and I think you have already noticed that we are spending a significant amount of time in discussing the nature based solutions, because that will be probably the most important takeaway from this course, that if we have to manage our ecosystem, we have to really understand nature based solutions good as possible. So today we'll be discussing, almost we are at the end of this discussion of nature based solutions. So we are discussing today challenges in designing and deploying nature based solution. In the last week, if you remember, we have discussed the three pillars of nature based solutions: blue green infrastructure, environmental engineering, ecological engineering, and then we discussed the application potential as well as the policy framework. And this week we will cover challenges in designing and deploying the NBS urban ecosystem assessment. In this, we will go for biodiversity, the ecological footprint, and the city biodiversity index. And we will conclude this particular module with the urban infrastructure assessment. So, today, for this barriers and challenges, to understand that, we will first talk about them. And these are the barriers we have identified for discussion: governance and institutional, regulatory and legal, technical and epistemic, integrated approach, financial, social and equity, and role of community, and climate uncertainty. And this entire discussion will be primarily with the case studies. We will discuss both the challenges as well as the solutions. The implementation gap in Indian urbanism of this NBS, we have already discussed a lot that there is a scientific consensus on this NBS efficacy for heat, flood, and water security. But then also the deployment is very sporadic, fragmented, and often maladaptive. So, why do Indian cities default to grey infrastructure, concrete drains, retaining walls, even when we know that they are not being able to manage the scenario fully or as per our expectation? Even when policy rhetoric always supports green, on paper at least. India requires 840 billion in urban infrastructure by 2036. Current spending is only half of that amount. So NBS is a serious contender for these scarce funds as well. So not only for its efficacy, but also as we have the resource crunch, we need to really look at beyond the grey solutions. As we discussed earlier also, implementation barriers, we have categorized them: governance and institutional, their silos and fragmentation; regulatory and legal, ambiguity in course and tenures, especially for the NVS; technical and epistemic, data gap, design norms, and cut paste failures. Integrated approach, we are really failing to integrate blue green with the green infrastructure. Add-ons are going on, but not a proper integration. Financial one, valuation of invisible services and funding models. Social and equity, displacement, gentrification, and disservices. If you remember, we discussed them. We will bring back with some examples. Community, very minor role playing for community we have seen in this case, which is not helping. Climate uncertainty, uncertain hydrology and performance models, they are becoming challenges. Barriers and examples, as I said, we will be discussing with the help of examples. First one is the governance and institutional. As we talked about institutional fragmentation, water and land, they are managed by different agencies with conflicting mandates. But when we talk about this NBS, we have to really integrate them. NBS requires basin level management, but bureaucracy operates at administrative silos. The consequence happens like no single agency is owning the blue green assets. Municipal corporations who are managing drainage, they are not in the same platform with the development authorities, who are actually having the authority for the land, or whereas the pollution control board who will be managing the quality. So these type of silos are really not helping the NBS propagation. Mithi River, a case in siloed governance. Mithi River, I think all of us, we do know probably that Mithi River is in Mumbai, and though it is a natural storm drain, now it has actually been a sewage drain. Controlled by the Municipal Corporation of Greater Mumbai, and downstream is managed by Mumbai Metropolitan Region Development Authority. So you just see the same stream, upstream and downstream, two different authorities. So that's the split. The failure is like that the 2005 floods and onwards, the Mithi River Development and Protection Authority was established to coordinate the efforts, and it remained toothless. Neither MMRDA nor this MCGM, they are coming on the same platform, and the Bandra Kurla complex, which is having very high pressure for the urban growth, they are narrowing the river, while MCGM failed to check the upstream encroachment. So that's the way the problem of choking the river is continuously there. The Nala syndrome. The river is administratively classified as a Nala, drain, not a river. This classification prioritizes desilting and channelization, that is the hydraulic efficiency, so that it can carry the wastewater. But it's actually, if it was a river, it was administratively classified as river, ecological prioritization could have happened for water quality, biodiversity. That is not happening. 85% of waste is entering this Mithi River, and that is untreated sewage. The river is treated as a waste conveyor and not an ecosystem. Regulatory and legal barriers, ambiguity in the land tenure and definition of forest. Again, an interesting example we will be discussing. Private landowners hesitate to implement nature-based solution like private conservation because they fear of losing the land right under the rigid conservation laws. Statutory gap is lack of a private conservancy legal framework in India. It is there for some special people, but not for all. That is also procedural barriers, zoning and building codes. Many existing zoning ordinances and building codes implicitly or explicitly mandate grey infrastructure. That's a regulatory barrier. Public participation mechanism is actually has a strong lack, and this leads to the rejection of NBS projects by the communities. So lot of more communication with the communities is important before going for a NBS. The legal this barrier, we will be bringing the discussion from the Kodagu Kurg in Karnataka. This is a biodiversity hotspot where 60 to 70% of the tree cover is on private coffee plantations. The deemed forest dilemma. The judgment in 1996 said any land resembling a forest can be classified as deemed forest. But the planter knows that if they allow native trees to grow, which can help in NBS, the land might be locked under the Forest Conservation Act, restricting the future use for their coffee plantation or something else. So the farmers actively clear the undergrowth to prevent their land from looking like a forest, undermining regional hydrology. So even if there is a need which they do understand, but they don't want to lose the control over their land. NBS requires adaptive management, but Indian law requires static land use. So Paisari lands, that's the wasteland, are diverted for infrastructure because they are not reserve forests, despite their ecological value as elephant corridors, hydrological impacts, etc. So, one part we were discussing the coffee plantation farms. Here we are discussing about the forest which are actually being utilized by the animals. Bidali mini hydel project, a wasteland forest, was diverted for a power project despite its ecological sensitivity. So, without legal innovations, conservation easements, regulation acts are acting as barrier to private stewardship. Next thing we'll be discussing, that is the technical and epistemic barriers, the cut paste ecology, importing models without adapting to the local biophysical conditions, prioritizing rapid visual greening over ecological function, lack of long-term monitoring data on species survival and soil health. I hope you remember we discussed all of them, especially from Tamil Nadu. We brought that information about this long-term monitoring on the species survival. Maintenance of NBS requires ecological literacy, and that ecological literacy shall be across specialization. A structural engineer also needs to understand that, as well as the policymakers. Grey infrastructure often fails visibly. There are leaks, there are cracks, but NBS can fail invisibly. So that failures also need to be monitored. The Miyawaki forest trend we were discussing in last week's lecture only. Adoption of this Japanese method, dense plantation of potential natural vegetation in cities like Mumbai, Chennai, Hyderabad is now while quite accepted. Context mismatch is the first strong criticism against this particular trend. This is designed for temperate or humid climates. Implementing it in the semi arid or grassland ecosystems like Deccan Plateau can be maladaptive. Water stress, high density 3 to 5 samples per square meter creates intense competition for water, often requiring irrigation in water scarce Indian cities. So, if you don't really have that irrigation system in place, which is having a very concentrated demand, in that case, you will be losing this investment on the saplings. So, you need to also have the survey that how many of them are surviving. That survey data is also very important. And this is also having a technical limitation like biodiversity versus biomass. That debate is going on. It will create a green wall rather than a functional forest. Species selection, often we are omitting the slow growing iconic native trees because we need it very fast. But this type of uh, changes or shifts are actually going to create long term impact on the soil and the environment. Extremely high capital cost, soil excavation and amendments, because you have to bring a different type of soil to have this type of forest. This forest is not meant for this particular locality. So it is making it unscalable compared to natural regeneration. Next barrier we'll be discussing, that is about the integration, the blue green and gray infrastructure that conflict, hostility between the blue green, that the natural one, and the gray infrastructure. Gray infrastructure, let's say, meant for the conveying the water first, the drain, whereas the green infrastructure is for infiltration. And if we have the blue infrastructure, that will also retain it, so water will also get recharged. The code barrier IRC SP42 road drainage, it mandates the rapid disposal of water to protect pavement, effectively banning water retention features such as biosoils near the roads. So there has to be some good dialogue among different groups so that the NBS can be actually integrated. Badshapur drain Gurugram. Gurugram's rapid urbanization has blocked these natural creeks and nalas in the inter urban area. The Badshapur drain was channelized and concreted to create space for real estate and roads. Concretization has prevented the groundwater recharge. You just see huge amount, 360,000 cubic meters per year is estimated as a lost opportunity for groundwater recharge. In 2016 and subsequently continuously, the Gurujam floods occurred because the smooth concrete channels are moving the water too fast. The runoff is too fast and it is going out. And where it is going to a bottleneck, that's a khansa, and there it is causing massive backflow. So ultimately, the city is facing more complex problem with the traffic jam, with the water being logged, and very unhygienic conditions. So when you try to understand that why this blue, green, and gray infrastructure integration failed in Gurugram, you can always see that natural creeks are acting as a sponges and you have to give it a chance to act. City planners are doing what? They are converting them into pipes, gray. So, loss of buffer capacity, the drains are becoming a hazard rather than an asset. They are creating vulnerability for the society now. You can see this type of images quite rampant in Badshapur and surrounding areas of Gurugram. Another very important barrier is the financial one, the invisible value of ecosystem services. Real estate value is visible and high, and transactions are going on. Ecosystem service value, flood control treatment, that is invisible and is diffused. The bankability of NBS projects is a significant barrier to attracting private finance. So, ecological arbitrage is destroying the nature for immediate financial gain through the real estate. So, this is a very, very strong debate or discussion which we need to really do quite regularly. East Kolkata wetland, we have discussed it in last week only, so we need not to go into the details of it. Ramsar site, and it is treating the 750 million liters of sewage per day naturally. So it is really saving the city from spending huge amount of money for every year, which they had to, in other cases, they had to go for the STP cost. So this is also supporting 1 lakh plus livelihood. But rampant encroachment by real estate, Salt Lake, Rajarhat, these are actually creating trouble to this particular area. Encroachments are making it smaller and smaller. You can see that here, that in the, if you compare with the 1991 image and you compare it with the 2017 image, you can see easily how the area has decreased for the East Kolkata wetland. The economic value of East Kolkata wetland has been proven, but then also the financial gain for the private developers is higher when converting water bodies into land, because there is a policy gap, lack of a payment for ecosystem services model that is not existing. Through this model, the government can pay the fishermen who is managing the wetlands. Fishermen, what they are doing, they are selling the land to the developers because the city is not paying them for treating its sewage. So it's a huge benefit or huge service they are actually extending to the city, and city is not recognizing that. So if that these valuations are coming into the place and is visible, then the nature-based solution will gain momentum. Tremendous momentum they will gain. Next barrier we will be discussing, that is social and equity barrier. Green gentrification and displacements, as we have discussed this particular barrier in details previously also, I will be very brief in this. Restoration projects often prioritizes aesthetics and leisure for the elite, and this leads to the eviction of the poor who rely on these commons for livelihood. So concept like bourgeois environmentalism, that is very much in discussion, because when you try to clean the environment, as a result the poor gets dislocated. We have seen it in most of the important projects, like in Delhi also, riverfront, Yamuna riverfront, we saw DDA's riverfront development project. Displacement happened to thousands of migrant farmers who cultivated the floodplains for generations. What happened? The NGT said no, it's a ban on this floodplain farming. And what is the reason? The reason is pollution. And the pollution is used as a tool to clear the land for recreational parks. You can see now, this is the present plan for this riverfront development. The farmers created a productive landscape, food security. Planners want a pristine or recreational landscape, park sort of thing. So the poors are displaced to resettle colonies on the periphery, and they lose the connection with the river, and the riverfront becomes a space for the leisure of the elite class again. So this social equity always is becoming a challenge, later on at least, to justify these nature-based solutions for everyone. Community barriers are also there. It is taken as a token and exclusive activities. Master plans often mark informal settlements as green zones or open spaces, rendering the residents invisible to service provision. Communities are treated as beneficiaries or encroachers, not partners in design. So, the social, institutional, technical, economic framework, that gap analysis is very important, and it is actually identifying that standard engineering, technical one, ignores the social one or the institutional one of the basti or slums. So, as a result, drains are getting clogged with the waste because there is no solid waste collection service in the informal settlement. Same thing happens about the water. The same thing happens about the stormwater drainage. So, in the Hyderabad, the case study we'll be discussing for these community barriers is from Hyderabad, Basti. Informal settlement are often located along nalas due to lack of affordable land. What municipal bodies are doing, they are refusing piped water or drainage to these areas because they are illegal. This forces residents to rely on informal and expensive water markets. The private markets are very expensive. So ultimately, the poorer people are actually bearing larger burden than the elite group. The counter example, we can see a success here. The team Jalam had brought an good intervention. They co-designed a stepped drainage. You can see in this image, they had designed this step drainage or water system with the residents in a hilltop basti to address the water leakage and slippery paths. A micro NBS managed the surface runoff, preventing the erosion while providing the safe mobility. So the water is also being moved as well as people can move from down to up or coming down. Technical solutions, wherever it fails, most of the time we find that community knowledge has not been integrated. So the best, if we are interested for successful cases, this community barrier has to be resolved, because they know best about the local challenges and terrains. Climate uncertainty barriers, the end of stationarity. Traditional civil engineering and even some of the NBS designs rely on the assumption of stationarity, the idea that the past is a reliable guide for the future. The past is no longer a predictor for the future. Rainfall intensity as well as the rainfall pattern, that is changing unpredictably. Building rigid infrastructure based on obsolete data is definitely a challenge. So, what we have seen in the case of Pune, Mulamutha riverfront development, they proposed the narrowing the river channel with concrete embankments to reclaim land. Again, the urban pressure. The flood lines based on the historical flood data, ignoring recent rain bombs and upstream dam discharge risk, they have gone for the traditional historical flood data. NGT has challenged it. Activists they argue that narrowing the river cross section will increase the flood height during the extreme events, and again it will endanger the city. So the engineers are saying channelizing will increase the velocity and the water will go out of the system. Ecologists are saying channelization will kill the riparian buffer and will increase the downstream flood risk. So that's the you just go through this particular image and you do understand the debate from different stakeholders. The climate lessons we can learn from this Pune case is nature-based solutions should expand room for the river, which we learned from the Netherlands case, not constrict it. The Pune case represents maladaptation, investment that increases the vulnerability. Even in case of Kyoto also you will find that providing room for the rivers is quite basic there, fundamental. So, the solutions, if we try to understand those barriers one by one for governance, unified watershed authority, not isolated authorities, hydro social cycle, not just the pipe, establish interdepartmental task forces, engineering, ecology, revenue department. They should talk to each other on a common platform. Payment for ecosystem services, pay the communities because they are providing ecosystem services. In the case of East Kolkata wetland, we have seen that sewage is being managed. Green bonds structure nature-based solutions projects to have a revenue streams. Treated water can be sold. You can attract investment, like we have discussed several green bond success. Addressing the technical standards, revise the IRC and the CPWD schedule of rates so that the relevant NBS items like vetiver planting, biosoils, these can be procured through the government process. Addressing the social equity, in situ adaptation, stop viewing the poor as encroachers who have to be removed. Rather, take them as a partner in the resilience mission. Design NBS with the community, co design. That is a very basic principle, fundamental principle for successful NBS. And it will solve their immediate needs, community's immediate need, as well as the long term ecological goals as well. And addressing social equity will also take care of the community barrier. So today we have discussed these implementation gaps and the barriers as well as the solutions which we try to learn from certain different cases. And I hope that's the way you people will be able to take the lessons from this particular course for the implementation. These are the references. Thank you.